Hello everyone, this is Chemical and Biochemical Kinetics lecture series. So suppose we have a reaction, we have here a hypothetical reaction A and B forming C and D. So what we want to uh, calculate or determine is yung tinatawag nating instantaneous rate of formation or consumption. So for example, since A and B are reactants of this reaction, so we want to determine kung gaano sila kabilis maubos, and ganoon din naman si C and D, we want to determine kung gaano sila kabilis mag-form. So let's denote the concentrations of A, B, C, and D as Ca, Cb, Cc, and Cd respectively. So if that's the case, we can express mathematically the instantaneous rate of consumption of A. So that will be the change in the concentration of A with respect to time. This is now the instantaneous rate of consumption of A, or of the disappearance of A. And you can do the same for species B. Now, on the other hand, we can also mathematically express the instantaneous rate of formation of C. So that will be change in the concentration of C with respect to time. Okay, so this is now the instantaneous rate of disappearance of C, and you can also do the same with species D. Now, we want to determine what we call unique reaction rate, okay, because this is the reaction rate that will describe the whole reaction, or will determine the rate of reaction, because we only have one reaction, right? So what we can do is we can relate all of these rates of formation, rates of disappearance in a single unique reaction rate. So this is now the relation, and take note, these are related by the stoichiometric coefficients of the species according to our hypothetical equation above. Okay, so ang isa pang mapapansin natin dito is that the rate for the disappearance of A and B, okay, is given as a negative sign or as a negative value. So for reactants, they will get negative, and for products, they will get positive. So for example, meron tayo ditong reaction. We have nitrogen reacting with hydrogen, producing your ammonia. All right? So we have determined that the rate of formation of ammonia is equal to 1.2 millimoles per cubic decimeter seconds. So letter A, I want to compute the rate of the consumption of nitrogen gas. Okay, so how do we calculate this? So ang gagawin ko muna, I would like to transform this reaction right here to a much simpler form. So instead of writing their formulas, I would just write here A plus 3B forming a product C. Okay? And from this reaction, we can now relate their rates, like the rate of formation of C or the rate of consumption of A and B, as follows. So we have the rate of consumption of A with respect to time, and this will be negative because it's a reactant, and this will be equal to 1 over 3 times the rate of the consumption also of B with respect to time, and this will also receive a negative sign, and we will equate this also with 1 over 2 the rate of formation of C with respect to time, positive. Now in letter A, we want to solve for the rate of consumption of nitrogen gas. So if you're going to look at our equation right here, nitrogen gas has unity as its coefficient in the reaction. So we are referring to A as the species for nitrogen. So therefore, we'll be utilizing this side of the equation, and we would like to relate it to the known value of the formation of ammonia. Therefore, we will relate it to this relationship or to this term here. So doing that, let's just write the equation that will result. So minus derivative of A, or the concentration of A rather, with respect to T, equals 1/2 times the change in the concentration of C with respect to time. Now we're after dCA dt, right? Because A corresponds to nitrogen, and that's what we're looking for here. So it will become negative 1/2 the change in the concentration of C with respect to time. And we actually have that value. It's given in the problem that the value for the rate of formation of ammonia is 1.2. So therefore, what you will calculate here, the result will be minus 0.6 millimoles per cubic decimeter second. So this is the answer, and take note of the negative sign because nitrogen is a reactant. So therefore, it will disappear according to the reaction. Now next, I want to calculate, letter B, the rate of consumption also of the other reactant, which is hydrogen, right? And in our symbolism, we use letter B to symbolize hydrogen. And take note also that according to the reaction, B has a coefficient of 3. Okay, so therefore, from our relation right here, what we're going to do is to relate B with C, or rather, we will relate the rate of change of B with the rate of change or the rate of formation of C, which the value is we know already. Okay, so we will utilize that. So rewriting that here, we'll get minus 1 over 3 um, dCB over dt equals 1/2 dCC over dt. Okay, so therefore, the change in the concentration would be with respect to time is equal to minus 3 over 2 dCC dt. And we will now substitute the value for the rate of formation of C, which is again 1.2. So therefore, what you will obtain here will be minus 1.8 millimoles per cubic decimeter second. So this is now the rate of consumption of hydrogen.